1,700 degrees Fahrenheit. That's hot enough to melt steel. That's the temperature NASA's Parker Solar Probe just survived, while flying at 430,000 miles per hour, just 3.8 million miles from the surface of the Sun. No human-made object has ever gotten this close to a star and lived to tell about it, and Parker has done it 28 times. Launched in August 2018, the Parker Solar Probe is humanity's first spacecraft to physically enter the Sun's outer atmosphere, the corona. Its mission? To answer questions scientists have had for decades. Why is the corona millions of degrees hotter than the surface below it? How does the solar wind, the stream of charged particles the Sun blasts into space, actually form? To get close enough to answer those questions, Parker uses something clever: gravity assists from Venus. Over 7 years, 7 Venus flybys gradually shrank its orbit, pulling it closer and closer to the Sun with each pass. On June 8, 2026, Parker completed its 28th perihelion, its closest point to the Sun. It matched its own record, 3.8 million miles from the solar surface. To put that in perspective, Mercury, the closest planet to the Sun, sits about 28 million miles away. Parker gets more than 7 times closer than that. Here's what makes this even more dramatic. For 9 full days around closest approach, the spacecraft was completely cut off from Earth. No commands, no signals, no contact. It operated entirely on its own, autonomously navigating one of the most hostile environments in the solar system. After those 9 days of silence, Parker phoned home. The beacon tone confirmed, all systems normal. During each solar encounter, which lasts about 10 days, Parker's 4 scientific instrument packages gather data from deep inside the Sun's corona. It's measuring the solar wind at its very source before it speeds up and spreads across the solar system. This is data no other spacecraft has ever been able to collect. Parker has also flown through some of the most powerful coronal mass ejections ever recorded, massive eruptions of plasma and magnetic field from the Sun. Understanding these events is critical because they can knock out satellites, disrupt GPS, damage power grids, and pose radiation risks to astronauts. One of the mission's most important long-term goals is capturing the full arc of the Sun's 11-year activity cycle. Parker launched during solar minimum, when the Sun is quiet. By 2024, the Sun had reached solar maximum, its most active phase. That means Parker's 28 encounters now cover the complete range, from a calm Sun to a stormy one. At closest approach, the heat shield on the front of the spacecraft reaches temperatures of around 1,700 degrees Fahrenheit. Yet just behind it, the instruments operate at room temperature. After 28 passes, the shield shows 0 signs of degradation. Scientists monitor the spacecraft's internal temperatures closely. Any upward drift would signal the shield is weakening. So far, perfectly stable. The probe is in excellent health. Parker Solar Probe will remain in its current orbit and keep making observations as the Sun transitions into the declining phase of its activity cycle. The next steps for the mission, from late 2026 onward, are currently under NASA review. Science data from the 28th encounter will be transmitted to Earth between June 17th and June 30th, 2026. Researchers around the world are already waiting to dig into it. The Parker Solar Probe is one of the most daring missions NASA has ever attempted, a spacecraft built to touch the Sun, and doing it again and again and again. Every close pass brings us closer to understanding the star that makes life on Earth possible. If you found this fascinating, hit subscribe. We will get back to you with another exciting space science story.